All right, quarter two, week 8, day 2. Find the quotient. All right, so we're going to divide 87 into 28,275. So I'm just going to go ahead and write that out. 87, divide that into 2, 8, 2, 7, 5. I have no idea whether I'm going to need decimals, so let's go ahead and put those there. All right, so does 87 go into 2? Nope, it doesn't. Does 87 go into 28? Nope. Does 87 go into 282? Yeah, I would say about 3 times. I don't think 4 would work, so I'm going to say 3 times. 7 times 3 is 21. 3 times 8 is 24, plus 2 more is 26. Well, as long as this answer is less than 78 or 87, I knew I did it correctly. So 2 minus 1 is 1. 8 minus 6 is 2. Yeah, that's way less than 87, so we're good. All right, so let's bring down the 7. So how many times would 87 go into 217? So I would say we would probably have to do that 2 times because 3 was too many. That'd be 261. All right, so 7 times 2 is 14. 2 times 8 is 16, plus 1 more is 17. Okay. All right, 7 minus 4 is 3. We're going to have to borrow from this 2 because we're going to have to make that 11. So 11 minus 7 is 4. So we have 43. And we'll bring down the 5. All right, so how many times would 87 go into 435? I would say probably 5 times. Okay, so I think it's going to be around there. Let's see. 7 times 5 is 35. 5 times 8 is 40. Plus 3 is 43. Works out perfect. Okay, so we have 0. Didn't need all those extra zeros that I made. So the answer is 325. That's how we find that quotient. Okay, now we have to find the product, which means we're doing a multiplication. All right, we don't have to line up the decimals, so it doesn't really matter. So I went ahead and rewrote it. 48.2 times 0.39. Let's go ahead and do the multiplication. 9 times 2 is 18. Carry the 1. 9 times 8 is 72. Plus 1 more, 73. 9 times 4 is 36. So 36 plus 7 is 43. All right, so then we'll put the spacer in there. We'll do the 3 now. 3 times 2 is 6. Nothing to carry. 3 times 8 is 24, so we'll put the 2 up here and the 4 down here. 3 times 4 is 12, plus 2 more is 14. So we have that. And then we have the 0 for the third one, but we're not even going to worry about that. So 8 plus nothing is 8. 6 plus 3 is 9. 4 plus 3 is 7. 4 and 4 is 8. And then we have 1. Okay, so we have 1, 2, 3 places to the right of the decimal, so we'll just move this over 3 places. So it ends up being 18.798. 18.798 would be the product of these two numbers. Once again, knowing that we're experts with greatest common factor and least common multiple, they just threw them both on the same square because it's just that easy for us. We're just that good. What is the greatest common factor of 64 and 32? All right, well, here's all the factors of 64 over here. Here's all the factors of 32 over here. What is the greatest number, the biggest number that it is in both of those lists? I see a 1 in both. I see a 2. I see a 4. I see an 8. I see a 16. And I see a 32. Okay, so the biggest number that is in both of them is 32. So the greatest common factor of 64 and 32 is 32. Let's look at the least common multiple. So we have multiples of 6, which are 6, 12, 18, 24, 30, 36. We're just counting by 6s, basically. Same thing with 4s, 4, 8, 12, 16, 20, 24. This time we want to see the multiple, but we want to have the least common multiple. So what is the lowest number in this list Because I see a 36 here. Okay, is that the lowest number that's in both of these lists? Okay, we have a 4, we have an 8, we have a 12 in both, right? So the lowest number that's in both of these is the 12. So that is our least common multiple. The least common multiple of 6 and 4 is 12. What is 55% of 125? Okay, remember, 55% is the same as 55 over 100. Okay, anytime you see a percent, you know it's that number over 100. And of course, if you turn that into a decimal, it's going to be 0.55. So that's also 55%. Okay, so all three of these things are the same value. All right, so we want to know what is 55% of 125. And when you see of, it means multiplication. So out of a 55%, 55 over 100 and 0.55, which one would be best to multiply times 125? Well, we can do 55 over 100 times 125 over 1. Okay, that would be one possibility. But I think I'm going to go with a decimal. So let's do 125 times 0.55. I could put the 0 there too. I just don't want to bother with it this time. 5 times 5 is 25. 5 times 2 is 10, plus 2 more is 12. 5 times 1 is 5, plus 1 more is 6. Okay, and then we'll put our little space there. 5 times 5 is still, it's actually going to be the same thing, isn't it? So we're just going to move everything over 625. All right, 5 plus nothing is 5. 5 plus 2 is 7. 6 plus 2 is 8. And we have a 6 there. How many places do we need to move the decimal? 2 places over 1, 2. So the answer is 68.75. All right. So 55% of 125 is 68.75. Okay, 68.75 is 55% of 125. And if you think about it logically, that's about half of 125, so that would be a reasonable answer. So I'm going to take it. We're good enough. All right, let's go on to the next one. All right, this says evaluate the expression, and we have a fraction, which sometimes causes quite a problem. But you know what? I'm going to use the number sense that we've gained to this point and make this a lot easier. So I can see that if we add the parentheses, 4 plus 1/3 is 4 1/3. And then we're just going to do 3 times that for our next answer. Okay, but what I'm going to do is I'm going to go ahead and use distributive property because we've been learning that, right? So, what I'm going to do is I'm going to distribute the 3 times the 4 and the 3 times 1/3 and rewrite this. Okay, so we have 3 to the 3rd power plus, okay, because I know that has to come later because it's on the other side of a plus sign. 3 times 4 is 12. And then 3 times 1/3, well, remember, 3 times 1/3 would be 3 over 1 times 1 over 3. Well, that's going to end up being 3 over 3, which is just 1, right? So it's going to be 12 plus 1. Okay, well, that's made life really easy, right? Just by using distributive property, made it so that we just have very easy numbers to work with. Now let's go back to the 3 to the 3rd power and do the exponent. 3 times 3 is 9. 9 times 3 is 27. So we're going to end up with 27 plus 12 plus 1. I guess we could have combined that and just made it 13. But 27 plus 12 would be 39, right? Plus 1 more is 40. So our answer to this one is 40. So sometimes utilizing the information that you have and the tools that you have makes things a lot easier when you're doing future problems. So there's the answer for that one. That is 40. Used distributive property to create an equivalent expression. All right, so we have 9x plus 21. So I've looked to see what is the biggest number we can divide into both 9 and 21. Well, it looks like 1 is in both groups, 3 is in both groups, and there's nothing larger than 3. So what I'm going to do is we're going to take the 3 and put that outside the parentheses. Okay, and then we just kind of factor those out. How many times does 3 go into 9? Or 9 divided by 3 is what? That's 3. So we have 3x plus 21 divided by 3 is 7. So we have 3x plus 7. So here's our equivalent expression. 3 times 3x plus 7. All right, that's all there is to that one. Cassie's book has 325 pages. She read 155 pages yesterday. Okay, so 325 total pages, 155 already read, and the rest she read, today. She read the rest of it today. Write an equation to express how many pages she read today. Okay, so we know the total number of pages is 325. Whenever we have that, just put that on one side of the equal sign, because that's our total. And she read 155 pages yesterday. And then we want to know how many pages she read today. Well, you're just going to have to add, right? Add the number of pages. I guess we can put P right there. So 155 plus whatever P is, the number of pages that she read today, will give us 325. All right, and then to solve that, all we would do is take 325 minus 155, and that would give us our answer. Okay, remember we just used the opposite operation of each side, so we'd subtract 155 and 155. Okay, and they're not asking us to do this, but if you wanted to know exactly how many pages, that's what you would do. All right, so anyway, but this is actually what they're looking for. 155 plus some variable, doesn't have to be the letter P, equals 325. All right, this time we solve for x. All right, we know how to solve for x. We just do the opposite operation of what is occurring currently in the equation. Okay, so we have 18 plus x. We got to get x by itself, so we're going to subtract 18 from both sides because this is addition. Okay, so the opposite of addition is obviously subtraction. So we're going to subtract 18 from both sides. All right, we know that a positive 18 and a negative 18 just becomes 0. So the only thing left on the right side of the equal sign is x. All right, and then we have this one here. We can't take 8 away from 7, so we're going to borrow from the 6, make it a 5. So 17 minus 8 is 9. 5 minus 1 is 4. Okay, so on this side it is 49. So x equals 49, and you can check that by putting in 49. Just put 49 plus 18 and see if that gives you 67, and it does. Okay, so 49 equals x, or x equals 49. You can write it either way, and that's fine. I like it better that x equals 49 first, or with the variable first, but you can do it either way, and that's fine. Okay, there's that one. Write the inequality this number line represents. All right, do you guys remember when we did the last one, we looked at this one, and was that circle colored in? It was not. Okay, since it wasn't colored in, we knew it was going to have to be one of these two, either greater than or less than, because we were not going to include the number that the dot was in, because it's not colored in. It was not going to include it. This one is colored in, which means we're going to include the number that has the dot above it. So it's going to be either this one or this one. Okay, so it's going to be either greater than or equal to, or less than or equal to. So we know that the number 2 is the one that has the dot above it. I'm going to put an x for the variable. And if you look at these numbers, are these numbers larger than 2, or are they smaller than 2? Well, since you're going to the left, they are smaller than 2. So x can be any of these numbers, and any of those numbers are going to be less than 2. But again, this is colored in, so it's going to be less than or equal to the number 2. All right, so there we go. We have two different ones, one colored in, one not, and now you know the difference.